Neil deGrasse Tyson had said that, if I'm not misquoting, that science needs better marketing. That we have engineers and scientists that are coming through their training, and they don't have any communication or presentation training, and they unfortunately have role models who they themselves had not had any presentation or communication training. And so we have this scenario where, and I don't know if we're actually getting worse because of that, if we're in a negative kind of a feedback loop where we're getting sloppier and sloppier with our communication in the scientific world. And I wonder sometimes, has this had a negative impact on science's ability to communicate issues like climate change, or for engineers communicating issues like cybersecurity?
So the answer almost certainly is yes. The problem that we run into, first of all, is that that which excites the engineers and the scientists may not excite the general public. I mean, some nitty-gritty little thing, or this little piece of the equation, or that particular measurement. Now, there are some cases where the excitement actually works. For example, the detection of gravity waves. Now, that was a big deal, and it was easily explained to people that it was Einstein's theory that such gravity waves would be generated by the collision of black holes. But we had no way of detecting that until somebody spent quite a bit of money, which is the National Science Foundation in this case, on iterating through 3 different designs for gravity wave detection and finally succeeding. So the general public got pretty excited about that because the scientists were excited. Most of the time, though, the implications of what the science implies is harder for the general public to infer on their own. And so that's where the scientists can be very helpful. If they can explain in fairly simple terms what it was that the science had taught them and why it was important. So when you see the correlation between carbon dioxide and percentages in the atmosphere and temperature, you begin to appreciate, especially if you've experienced high temperatures or particularly bad climate dynamics or major storms of one kind, weather events, you begin to appreciate why this might be important to you. Or if you read headlines or see videos of flooding, for example, or hurricanes that blow down half of the island, like in Puerto Rico. So getting scientists to learn how to communicate is important, especially when they have to recognize what's important to the audience that they're talking to may not be the thing that's important to them. We do have some very serious problems, and it's not about communicating technical information at all. It's about gaining the trust of the general public in science. And I'll give you a scenario which illustrates why this turns out to be hard. Let's suppose, for the sake of argument, that you're a noted scientist and you've been studying some particular phenomenon about health. And I come to you, let's say 10 years ago, and I'm worried about this health problem. So I ask you, what's your best advice? How should I defend myself against this problem? And you say to me, you should do X, or some value of X. Now let's imagine that 10 years have gone by. You've been studying this problem for another decade, and I come back to you and I say, well, thank you for that advice you gave me 10 years ago. What is your advice now? You've been studying this for another decade, and you say, well, I had a theory before, and the theory said you should do X, but I have a better measurement now, and I have better understanding, and now my theory says you should do Y for some value of Y. There are 2 kinds of people in the world. The first one will say, thank you for giving me this extra advice, this new advice, and I realize it's different, but you've been studying the problem for a decade. The second person looks at you and says, so you lied to me 10 years ago. And you're sitting there saying, no, I gave you the best advice I had. It was based on the best model I had. And now I've accepted a change in my own model. I wasn't clinging to my theory and rejecting the data that I got. I adapted the theory to match the data. And this person will say, not only did you lie to me 10 years ago, but now I don't believe. Why? Either because of the fact that you lied to me 10 years ago. And that's the situation that we find ourselves in many cases, where people are they misunderstand and think that science is absolute truth. You hear scientific evidence that, scientific proof that. Well, a good scientist will tell you that science is about successive approximation of how the real world works. It's successive improvements in models and ability to predict. Confirmation by making measurements, acceptance that a theory might have to be discarded because the evidence of measurement tells you otherwise. There are a lot of people who are very uncomfortable with that. No amount of factual assertion and explaining of the experiment and explaining of the model will overcome some people's rejection on the grounds that they just don't want to believe that that this new theory is better than the old one. They wanted science to be absolute and unchanging. That's a very difficult cohort to deal with.